For this, how to do partial fraction decomposition, all right? Reagan, let's read the instruction, 4, 6, 7, and 8. Thank you.
For the following exercises, find the decomposition of the partial fraction for the non-repeating linear factors.
Thank you, right? So good thing we have an instruction already in here that the denominators that we are considering are what? Non-repeating and linear factors, okay? So we're not gonna see any exponent, right? And the factors are all linear. Let's try number 6 for now, right? So with number 6, we have the following. 5x plus 16 all over, what's this? X squared plus 10x plus 24. Okay. Now, let's read our first step for such. Step number 1, all right? Marguerite, let's read that one here.
Factor given denominator such that all are linear and degree 1.
Thank you, right? So again, just the denominator, right? X squared plus 10x plus 24. Again, you can do quadratic factoring, you can do quadratic formula, you can do graphing it, right? Just get the factors, right? What do you think will be the factors of that, right? 5x plus 16, oh well, sorry, 5x, x squared plus 10x plus 24 can be factored as what? 6 and 4. Very good, right? That's correct. X plus 6, x plus 4. Are we good? Get it, guys, right? Yeah. So again, verifying it, if you want to do FOIL method, right? That's x squared, outer 4x, inner 6x, added together 10x. Last term, 6 times 4, 24. And again, by graphing the denominator only, you can see that it hits -6 and -4. Are we good? Got it, guys? Okay. Check. Are they linear? Well, they're both x degree 1, right? Are they non-repeating or degree 1? Yes, there's no exponent, right? Well, there is 1, right? So it's not repeated. Get it? Okay. Step number 2, right? Let's read step number 2. Candy, go ahead.
Write in the form k over x plus b1 times x plus b2 equals a over x plus b1 plus b over x plus b2.
Thank you, right? That ellipsis in there, actually ellipsis is just 3 dots, right? In short, it may continue depending on how many factors you have, right? In here, since there's just 2, then we only have just 2. Good? But if there's 3, then you have 3. And so on. Get it? Right. But typically, our problems in here are typically friendly. 2 will be fine. Get it? Okay. So with that, then I can express this one now as follows. So here it is. That is equal to a over the first factor, denominator, x plus 6, right? Okay. Plus b over the second factor, x plus 4. Good. So that's what we mean by that, right? We split. Yes, question, Aiden.
I don't have the paper.
Oh yeah, I'm gonna give you the paper in there. Sorry for that one. It's on our worksheet, guys. Number, what's this? 6, right? But yeah, I'm gonna give you a paper right away. Oh, by the way, here it is. Okay. All right, let us continue with question number 2. We good? Oh well, step number 2, right? Okay. Now, let us read step number 3 and how we can continue with this one, guys, right? So again, number 6. Okay. Step number 3. Let's read this one. McKinsey. Go ahead.
Remove denominator by multiplication property.
Thank you, right? We want to get rid of the denominator by what? Multiplying all the terms, each of these fractions by what? By this. Get it? So let's do that one in here. Ready, guys? So again, we want to get rid of the entire denominator. And how do we do that? We multiply all of them, each of them, by this, what we call the LCD, the least common denominator, right? And this is the least common denominator. Let's do it in here. Oops. No. In there. X plus 6, x plus 4. Same in here. X plus 6, x plus 4. And same in here. X plus 6, x plus 4. You good? right? What's gonna happen? On the left side, what's gonna happen to this and this? Right? Okay. This and this cancel out, right? So the left side, you are left with that, right? 5x plus 16 on the left side. Get it? Okay. Oh, what's gonna happen to this? The first fraction in here on the right. Is something gonna cancel out? Eva?
X plus.
The x plus 6 will cancel out. Very good. And the a will be what? Multiply, right? 2x plus 4, right? So put in here is equal to a times x plus 4, the factor that's left in there, right? Now, what do you think will happen in here?
It would be
B times x plus 6, right? Very good. Madeline, the x plus 4 is gone, right? And your b is multiplied to x plus 6. How we did? Get it, guys, what we did? Okay, so again, the goal for that one is to what? Well, we definitely don't like fraction in a equation, right? So as much as we can, we want to get rid of this fraction or denominator at least right away. Get it? Okay. What's next? Step number 4. All right. Let's read our step number 4 in here. Anna.
Solve for the x using one of the denominators and use this value to solve for a.
Thank you. Right. Solve for x on one or using one of the denominators. Right. For example, what is one of the denominators? X plus 6. Right. So let's choose the denominator 1. Okay. This one has no ink anymore. The first denominator that we chose a while ago is what? X plus 6, right? So x plus 6, we equate it to 0 and solve for x, right? So again, this first denominator, x plus 6, that we considered a while ago, equate it to 0 and solve for x. And what's your x in there? Negative 6, very good, right? Now what do you do with that negative 6? It says in there, use this value to solve for a in this case, right? Or sometimes b. Well, let's see, right? So let's put this one on those x's, right? So I'm gonna put it in here like such. At x negative 6, right? What's that gonna be? 5 times negative 6 plus 16 is equal to what in here? A times, what's this? Negative 6 plus 4, and this will be what? Plus b times negative 6 plus 6. Again, so I just replaced those x's with what? Negative 6. Are we good, guys? Okay, so what's gonna happen? So again, these x's were replaced by the negative 6, okay? Well, we can use our calculator. What's on the left side? What's that gonna be? 5 times negative 6 plus 16. Calculator. Decimals TI. Go ahead and do it, guys. What will you get? Okay. Yeah, you can move in here. Absolutely.
No, I didn't get the exercise.
Oh, the exercise paper, yes. Okay. So what do you get, guys? 5 times negative 6 plus 16. Sorry for that. Negative 14. Thank you. So you get negative 14, right? So let's put it in here. Here we go. Negative 14. Oops. What's this gonna be? Negative 6 plus 4 is negative 2 times a. Basically just negative 2a. What's gonna happen here? It's gone, right? Right? Well, you can solve for a, right? Dividing negative 2 on both sides. What a value will you?
So does the b cancel out with that?
The b times, what's this? 0, right? And by 0 product rule, 0 times any number is gone, right? So it's gonna remove everything. But yes, that's a good question, Anna, right? A 0 product rule tells us that what? 0 multiplied to any number will be gone, right? 0. Okay? Anyways, what's our a value for such? Okay? What you got? Emma? What you got? What's negative 14 equals negative 2a? What do you do on both sides? Divide by negative 2, right? And what's that gonna be? Negative 14 divided by negative 2? 7. Positive 7. Very good, right? So leave it as it is. Almost done. We just need to do the same thing on the second denominator, the x plus 4. We good? Right? So let's do that one in here, this time for x plus 4. So I'm going to put this in here as well, and put in here what? Second denominator. And what is that? X plus 4 is equal to 0. Hence, your x in there is what then? Negative 4. Get it? So x equals negative 4. And again, we're going to do the same thing all over again. This time, replace x with negative 4 instead. Are we good? Right? Let's do this. Going back, what's this? 5 times negative 4 plus 16 is equal to a times negative 4 plus 4 plus b times negative 4 plus 6. All right? Once again, the x's a while ago, replace those with negative 4 in here instead. Okay? Get it? In this case, which one will cancel out? The a. Very good, right? So the a in here will cancel out. Thank you. Again, by zero product rule. What's going to be the left side? What's that? 5 times negative 4 plus 16. What's that going to be, guys? Negative 4, right? Very good. Is equal to, what's your b going to be? Negative 4 plus 6. 2. B, right? And with that being said, what is our b then? Negative 2. Right? Dividing both sides by 2, then b is negative 2. Right? So we have solved for A, checked. We have solved for B, checked. Get it? Okay. Well, what's next? We're almost done, right? We're almost done in here. So that's what we mean in here by step number 5, right? Repeat step number 4 for each denominator, right? In that case, we have 2 to solve for B, etc. We get, right? That's what we did. Just repeat the whole thing for the second denominator. If there's third, right? It's kind of rare if there's a fourth, right? Yeah. Typically, it's just basically 2 denominators. Excuse me. Last step, number 6, right? Let's step number 6. Let's read this one in here, right? Kaden, can you see it from there? Rewrite
Rewrite the partial fractions. Solve A, B values, verify by graph.
Thank you, right? So I'm just gonna put it in here, guys. That means this one, what number are we solving for again, by the way? Number 6, right? So let me put it in here, number 6. 5x plus 16, x squared plus 10x plus 24 can now be written as, what's our a, by the way? 7, right? So that can be written as follows, number 6. And here it is. Can be written as follows, right? Our a is 7 over what? What's over a? X plus 6. Right. And what's our b? Negative 2, right? So I put it in here. Minus 2 instead of plus, because it's negative, right? Minus 2 over what? X plus 4. So again, we can split that one fraction into 2 fractions as such. And how do we verify it by graphing? Well, let's put it in our calculator and see how it looks like. What's this once again? 5x plus 16 over, what's that again? X squared. What's next? Plus 10x plus 24. Right, so let me just click on home, how the graph looks like. See that graph, guys? Okay. Now, let's put it on our answer, right? What's our answer in here? 7 over x plus 6, right? And then plus negative 2, which is basically minus 2, over x plus 4, right? Get it? Okay. So what do we notice? Well, the blue graph, our answer, and the red graph, the given, are basically the same. We good? So that verifies by graph that we have actually split this one entire rational expression into 2 simple rational expressions. And how do we, why do we do this, right? We do this one because for those who are in calculus track, there's a certain type of integration, right? That you have to do integration by partial fraction. That you have to split a complexly written rational expression into two simple fractions or algebraic expressions, right? Or rational expressions in order to integrate it, right? So this is particularly important for the calculus level, specifically the integration part of calculus, okay? Any questions? Yes?
So if we would have solved for b and know it's positive 2, would we make the like operation like?
Yeah, if should this have been positive 2, then you put plus 2, right? I just put minus 2 because it's plus negative 2, which is basically minus 2. Are we good? Questions, guys? Questions? Okay, 1 minute. Okay,